Hi, this is Brian with Capacitor King. In this video, we're going to make capacitor talk simple. First of all, we're going to go over the basics, which is going to be voltage and amps. And so you get an easier understanding of that. I'm going to start out with the voltage. And just like in any kind of electrical repair, always turn the power off if possible and take every safety precaution. So, voltage, if we could kind of put this in a lay term, we'll just kind of compare it to a garden hose. And with the garden hose, the voltage would be equal to the pressure. How much pressure is at the nozzle? And the amperage would be equal to how much water's coming out, how much flow, how much current, which is, current is also another name for amperage. So we got pressure and flow or current. So voltage equals pressure, amperage equals flow, and then the definition, we'll go over that and then we'll get started on the actual lighting capacitors. The definition of a capacitor is a device of electrical storage, kind of like a battery, that will charge up and acts as a restrictor valve and a check valve. Okay, so the restrictor part of this, the restrictor valve part of the lighting capacitor is called current limiting, which is fancy talk for it only allows so much flow out. So the capacitor allows the bulb to have the required amount of power to make it efficient and as bright as it can be without overcharging. And if you didn't have that part of the lighting capacitor on it, it could draw twice the amps. You wouldn't get that much more light. It would overheat the fixture. The transformer would be on overloaded more than it's designed for, because the transformer is only designed to put out the amount of power that's required by the bulb. So that's the first part. You know, they limit current. And then the other part that I oversimplified for you, and I call it like a check valve part, that keeps the voltage constant. So it doesn't dip, it doesn't spike, it fills up the capacitor with energy and it keeps it even. So it only allows out so much and then keeps the pressure even. That's why we're talking about the voltage, the pressure. So that correlates with, if it's 120, it keeps it at 120, not 90 volts, because at 90 volts, if the supply voltage went down to about 90 volts and somebody kicked on a big motor or some big draw of electric on the line, it could cause the arc tube to extinguish, because it needs to have somewhere, it can maybe dip about 10%. So you have the supply voltage or pressure, whatever you pick. Supply meaning that's what you're feeding the transformer with from the line. So you got that goes into the primary part of this transformer. A transformer is just a transformer. All it's taking is whatever you're feeding it with, 120, 208, 277, 480, and it's making it whatever the bulb requires voltage, which is the operating circuit voltage, or the abbreviation is OCV. And with the OCV, that's very important, and we'll get into that in the next video.